Um, okay, so here's what I'm going to do. First of all, I'm just going to take care of the special case of the list being empty. Um, sorry, more Windows management going on here. All right. So now I'm going to say, I'm going to copy the first node in the original list. Okay, so that's basically just, I just made a copy of the first node in the list. Now I'm going to get a pointer to the source list, which was copy me, and a pointer to the new list, both of which are going to be sort of current pointers that go down the list as we're building the new list. So here's my pointer that's going to point to the current node in the new list that we're building. Here's my pointer that is going to point at the original, at the current node in the original list. Okay. And what I have here, I have a comment over here. Let me just copy and paste that in. Maybe it will help. Okay, so what I have is I'm going to get source pointer and new list pointer set up to copy the remaining nodes. New list pointer is always going to point to the last node we just created in the new list. Source pointer is always going to point to the next node about to be copied in the original list. Okay. Okay, so now we just need a while loop to copy the rest of the list. While source pointer is not equal to null pointer. That makes sense, right? I'm just saying while the next node that's about to be copied is not, well, exists, right? I'm going to add a new node to the end of the new list. I'm going to move new list pointer down to the newly added node. I guess I should be drawing pictures of all of this. I'm going to put the data in. And then I'm going to move source pointer down to the next one so that it's pointing to the next node that's going to be copied. Okay. I am going to go back and draw a picture of this because I can imagine that if this is the first time you've seen something like this, it's probably not easy to to follow. And then the only other thing I need to do is I need to make sure that the new list that I just created in that while loop ends with null pointer. Okay. I'm thinking that this is in a namespace, right? And the namespace, I don't have an end to the namespace. Oh, it's at the very bottom. Okay. So this actually technically should be indented. That's a bummer. Let me. Okay. So this is going to be a challenge. Let's see how this goes. There must be a way to get rid of the zoom controls. Okay, so let's say we're making a copy of a list. So I've got, let's say this,
Should we be able to see what you're
oh,
drawing
yeah,
right now?
yes, thank you. Not that I've gotten very far, but so I discovered recently that Excel is actually a pretty good way to draw linked lists on a computer. If I can remember, how I got the, I can't remember how I did the picture, the arrows. How do you draw in Excel? Insert. Huh. All right, we'll see how this goes. Ugh. It really did work pretty well last time I did it. So here's the linked list that I want to make a copy of. Let me just get 3 nodes going here. Can I copy and paste that? Sort of. Okay, and then this last one is going to be null pointer. So let's just say that, for example, I've got, 9, 42, 17 in here. So let's just trace through this code here. Copy. So this is an object named copy me. So I'm going to up here say, actually, this will be a pointer variable, and it's going to be named copy me dot list. And it's going to be a pointer from If anyone has any suggestions on a quicker way to get back to the picture drawing, feel free to type in. But so that's pointing to the first node in the list. Okay, so that's what we're coming in with. And we've got a calling object. So I could call that this arrow list. And it's gonna, right now it's a null pointer, okay? All right, so I'm gonna say list gets new node. So that means I'm creating a new node on the heap. Let's make it here. And let's make list point to the new node that we just created. Okay, so what I just did is the result of the first line there, list gets new node. Now I'm going to say list arrow data gets copy me dot list arrow data. So that means I'm going to put a 9 in here. Now I'm down here. I'm going to create these two new pointers. I'm going to create a pointer called new list pointer that's going to point at list. So here's new list pointer. And it's going to point at the same thing that list is pointing at. Stop me if I do anything here that doesn't make sense. It's not going to do that. Okay. So that's the line new list pointer gets list. Now I'm going to say source pointer gets copy me dot list arrow next. So that means source pointer is going to point at the 42. Okay, so that's the result of this line source pointer gets copy me dot list arrow next. Okay. Notice what I'm doing here. I didn't do this very well, but I sort of did it. Everything in column B is on the stack, and everything out here to the right of column B is on the heap. If I had to do it again, I'd separate that out a little more, but there we have it. Okay, so we are ready to enter the while loop now. So we're going to say new list pointer arrow next gets new node. So new list pointer arrow next gets new node. That means this node's going to be pointing at a new node. Okay, so that's the result of new list arrow next gets new node. New list pointer gets new list pointer arrow next. So that means make new list pointer point at the thing that new list pointer arrow next is pointing at. So that just means this arrow here is going to have to get moved. I wonder if I can just, yeah. Okay, so basically what I should have been doing is copy and paste. Okay, so that's the result of the statement new list pointer gets new list pointer arrow next. Now new list pointer arrow data gets source pointer arrow data. New list pointer arrow data gets source pointer arrow data. So that means we're going to put a 42 here. And then source pointer gets source pointer arrow next. So that's just going to move this down. Oops, here. Okay, so we've reached the bottom of the while loop, and we have maintained our setup of having source pointer pointing at the next node that needs to be copied, and new list pointer pointing at the last node that was just created. Okay, so now we're going to go back up to the top of the while loop, do that again. New list pointer arrow next gets new node. So I'm going to create a new node and make new list pointer point to it. New list pointer gets new list pointer arrow next. Oops, wait, that's what I just did. New list pointer arrow next gets new node. Oh, sorry, back up, I totally did that wrong. This is what we had. New list pointer arrow next gets new node means I'm creating a new node and I'm making new list pointer arrow next point to it. So like that. Okay, so that's the result of the statement, new list pointer arrow next gets new node. Now I'm going to say new list pointer gets new list pointer arrow next. In other words, make new list pointer point at the same thing that new list pointer arrow next is pointing at. Okay. New list pointer arrow data gets source pointer arrow data. So the 17 comes down here. Source pointer gets source pointer arrow next. So now source pointer is null pointer. I'm going to indicate that by just putting the arrow inside the box, I guess. Okay, so after that last statement, source pointer is now going to be equal to null pointer. So when I go back up to the top of the while loop, source pointer, so this condition is now false, right? So we exit the while loop. Then the last thing we have to do is we have to say new list pointer arrow next gets null pointer. So that just means make this one point at null pointer, and we're done. Okay, so we have successfully made an exact copy of this list up here. Anybody want to ask a question? I know that's fairly intense, especially if it's the first time you've seen it. You may want to go back and do that on your own a few times just to make sure you understand everything that's going on there. Everybody good? Okay. So that's our clone function. The other function that we're going to need in order to accomplish the big three is we're going to need a function that completely deallocates the entire list. So basically the way we're going to do that, actually let's go, oh, I know you guys can't see this, hold on. Hold on. Okay, so back to our header file. I'm going to uncomment the clear function now. That's the function that's going to deallocate the entire linked list. Okay, so the way we're going to do that is I'm going to create a temp pointer that is going to point to each item in the list successively. as long as temp pointer is not equal to null pointer, I'm going to move list down, delete temp pointer, and then move temp pointer down to point at the same thing that the list is pointing at. Okay, so if we want to just trace through that, let's say that we call clear on this list here. So let me call this, I'm going to create a pointer called temp pointer, and it's going to point at the same thing that list is pointing at. Okay, while temp pointer is not equal to null pointer, move list down. Delete temp pointer. So now this is gone. How can I indicate that? Let's just color it red. Oop, that's not what I need to do. Color it red, meaning that that has now been deallocated. And then temp pointer gets list. Make temp pointer point at the same thing the list is pointing at. Okay. Back up to the top of the loop. Temp pointer is still not equal to null pointer. So I'm going to move list down to list arrow next. I'm going to delete temp pointer, which means that now this 42 is going to be deallocated. And then I'm going to set temp pointer equal to this so that it points to the same thing that list is pointing at. Okay, back up to the top of the loop. Temp pointer is still not equal to null pointer. List gets list arrow next, is going to make list now be equal to null pointer. So I'm going to indicate that. I'm doing this in here. Delete temp pointer means deallocate this node here that has a 17 in it. And then temp pointer gets list, in this case, is going to make temp pointer also equal to null pointer. So I'll just something like that. Okay, back up to the top of the while loop. Temp pointer is now equal to null pointer, so we're done. And we've successfully deallocated every node in that list. Any questions about that? Okay, since I have those two functions, and this is something that's kind of cool about the approach that I'm using here. Basically, if I have these two functions, my big three, I can copy and paste them into any class, and they're going to be exactly the same. So let me just bring them up here since I already have them here. This is all stuff that I retyped. But, okay, so here's my actual big three. Here's my copy constructor. All I do is I just call clone. Here's my destructor. All I do is I just call clear. Here's my assignment operator. The assignment operator includes a couple other things. I have to check for, I have to check for self-assignment. So if the calling object and the parameter are not the same object, then I'm going to call clear and then call clean. And then when I'm done, the assignment operator, of course, needs to return the calling object. Okay. Notice the bodies of these three functions don't say anything at all about the actual kind of object. So I literally can just copy and paste those bodies into whatever class I'm writing if I have written a copy function and a clear function. All right. Any questions about any of that? Okay. I think, unless there are any requests, I'm thinking that I may just stop there for today. I think that you're in pretty good shape now to work on assignment 4. Maybe we can just bring it up here for a minute. And if there are any requests, feel free to ask me. But oops, you're not supposed to see that. Let me. Oh my gosh. Okay, I'm going to share my browser if I can find it. Okay, so here's our class website. Assignment 4. Basically, just doing the same thing that you did in assignment 3, except now using linked list instead of arrays. Same as assignment 3. You're going to still have your class. Your class is still going to be derived from the set interface abstract class. You should be able to use the exact same set interface class that you used in assignment 3. You must provide the big 3. The linked bag from the links below provides a copy constructor, but does not provide an overloaded assignment operator. So you're going to have to add an overloaded assignment operator. That's just a little suggestion about an exercise you can do to make sure you understand about copy constructor. I guess the thing I did not do is actually test our code to see if it works or not. But I guess I'll just ask you to take my word for it. Here's my suggestion about the big 3. Change the given copy constructor into a function named copy. And then you can just do what I did, where you call that function from both the copy constructor and the assignment operator. Here's an interesting point. So a subtle point about the copy function that I'm suggesting, it should be private because it won't be appropriate for the client to call this function because it doesn't deallocate an already existing linked bag. So the copy function that we wrote assumes that we are creating a new simple list object from scratch, not that we are replacing an already existing one. So that's kind of a subtle point. What it basically means is that it's not going to make sense to call it from any place else, basically, except the copy constructor and the assignment operator. So anyway, there's the code, and then just like last week, you're going to write set union, set intersection, and set difference. I'm going to be a little bit mean about it this time. I'm going to say you can use the contains function, but other than that, I'm not going to let you use any function calls in your definitions of those 3 functions. The reason being, I want you to have to work on your linked list manipulation skills. So you're just going to have to write those from scratch without calling any other functions. I think that's about it. Anything else you guys want to talk about? All good?
Yeah, I think I'm all good.
All right. Kind of looking forward to next week. We get to talk about some fun stuff. The recursion chapter in the textbook is kind of interesting because he throws some things in there that are like just vaguely related to recursion. Kind of feels to me almost like he couldn't think of any place else to put them, so he threw them in there. So we will, they are important things though, so we're going to be talking about those next week. All right. If there aren't any other questions, I'm going to end the meeting. I'll see you guys next week.
Yep. So thank you so much.
Thank you.
Thank you, Dave.
Thanks.
All right.